Let us look at the next section, students. This section contains two matrix match the column type questions. Entries given in column 1 have to be matched with entries given in column 2. For every entry given in column 1, there may be one or more entry in column 2 which will be matched with it. Okay. So let us look at the first column now, starting with AG2O. So AG2O, if you look at the options on the column 2, we can clearly see that it is about soluble in excess of NaOH or NH4OH. So if we talk about option A, students, we have AG2O. So if we talk about its reaction with NaOH, it does not dissolve in NaOH. If we talk about its reaction with NH4OH, so it dissolves in NH4OH to give us the silver diamine complex. Okay, so A will be matched with Q, which is insoluble in NaOH, and it will be matched with R, which says that it is soluble in excess of NH4OH solution. So A will be matched with Q and R. If we talk about Hg2O, so Hg2O does not dissolve in either NaOH or NH4OH. So it is insoluble in NaOH and it is insoluble in NH4OH as well. So B has to be matched with Q and S. Okay. If we talk about option C now, it is NiOH whole twice. So it is a basic hydroxide. It does not dissolve in excess NaOH. If we talk about its reaction with ammonia or NH4OH solution, so this will again be dissolved, forming the hexa-coordinated complex, which is deep blue in color. Okay. So if we talk about option C, it is insoluble in excess of NaOH. So Q will be a match. R will be a match, that it is soluble in excess of NH4OH. So QR. And if we talk about the last one, it says there is deep blue solution in presence of excess of NH4OH solution. So this will also be a match, students. So C has to be matched with Q, R and T. If we talk about the last one, which is CuOH whole twice, so this will also be insoluble in excess NaOH. If we talk about its reaction with ammonia or NH4OH, we're going to have the formation of CuNH3 whole 4 2 positive, which is also deep blue in color. Okay, so this has to be matched with Q, that it is insoluble in NaOH. It has to be matched with R, that it is soluble in excess NH4OH, and it has to be matched with T, which says that it has a deep blue coloration in presence of excess of ammonia. So students, we have the correct matching for this question. Let us look at the next question now. Question number 37. A, B and C are three complexes of chromium 3 with the empirical formula H12O16 Cl3Cr. All these three complexes have water and Cl- ions as ligands. Complex A does not react with concentrated H2SO4, whereas complexes B and C loses 6.75 and 13.5% of their original mass respectively on treatment with concentrated H2SO4. Okay. So if we talk about complex A, students, it does not react with concentrated H2SO4. It means that there is no water outside the coordination sphere. Okay. So if we talk about the complex A, it has to be CrH2O6 Cl3. Okay. So it does not react with H2SO4. Okay. If you talk about complex B now, it loses 6.75%. So it has to have only one H2O molecule outside. So we have CrH2O5 Cl Cl2 dot H2O. Whereas if we talk about the compound C, it loses 13.5% of its mass as water molecules. So it has to be 2H2O, since the first compound it lost 6.75%. So we are going to have CrH2O4 Cl2 Cl dot 2H2O. Okay, so these are the three complexes which are mentioned to us, students. Okay, so if we talk about the complex A, the complex A has to be matched with Q. Okay, and if we talk about the number of geometrical isomers, the complex A is not going to have any geometrical isomers, so it has to be matched with T as well. If we talk about the complex B now, in the complex B, the 5 water molecules are inside the coordination sphere, so it has to be matched with P. Okay, and this compound as well, it does not have any geometrical isomers, so it has to be matched with T as well. If we talk about the complex C now, in the complex C we have 4 water molecules inside the coordination sphere, So R has to be matched with C. Okay. If you talk about the number of geometrical isomers, there will be two geometrical isomers for this. The chlorine can be cis with respect to each other, or the chlorines can be trans with respect to each other. So it has to be matched with S. If you talk about the complex given in option D now, it says complex which absorbs light of maximum wavelength. So the complex which absorbs light of maximum wavelength has to have the maximum number of weak ligands. If you talk about H2O and Cl2, H2O is a stronger ligand than Cl. So the complex which is going to have the maximum number of weak ligands is going to be the complex C. So the option D is going to have the same matching as option C. So it will be matched with R and S. So students, we have the correct matching for question number 37 as well.